All right, guys, hey, let's go. So today, up here. Thank you. We're kind of be all over the place today. We're doing like 4 different things, but we're not going to take a ton of time on any of them. All right. Besides the last one. Last one take a little more time, but it's really not difficult. A lot of what we're doing yesterday put into today. The last 2 things. On that, so we're going to talk about. I guess I can't use this. We're going to evaluate functions. We've done this before. This is old news. We're going to practice it again. We're going to understand the meaning of solutions related to the graph. So when we talk about the graphs on day 1, guys, when we talked about finding solutions on a graph for quadratics, what did we say? Where were our solutions? When our graph hit what?
0.
Not 0. The x-axis. Thank you. So when it hit the x-axis, so we're going to talk about what that actually means in accordance to solutions today. And then we're going to convert between equations when a is greater than 1. That should say 1, not 0. Because yesterday everything we had is just x squared, right? Today we're going to throw in like 3x squared or 4x squared, make it a little bit more challenging. So that's the kind of stuff we're going to do today. First and foremost, evaluating functions. We should all know how to do this. It'll go. If I ask you to find f of 1 plus f of 3, and you're given the function f of x equals 3x squared minus 2x plus 5, what are you going to do? Ange?
You're going to first fill in f of 1 for the equation?
Yeah, find both of them. Find f of 1 first. Plug 1 in for x in all the spots. 3 times 1 squared minus 2 times 1 plus 5. Find f of 1. We've done that before. We've done f of something. Plugged it in. We get 1 squared is 1 times 3 is 3. Negative 2 times 1 is negative 2 and plus 5. Right? Did I jumped a couple steps there? Is that okay?
Yeah.
We all understand that? Okay. 3 minus 2 is 1 plus 5 is 6. So f of 1 is 6. So I need to now find f of 3. Well, f of 3. Plug 3 in for x. 3 times 3 squared minus 2 times 3 plus 5. Okay, 3 squared is 9 times 3 is 27. Minus 2 times 3 is 6 plus 5. Right? You all follow me?
Yeah.
27 minus 6 is 21, plus 5 is 26. So f of 1 is 6, f of 3 is 26. I add those together, and what do I get?
32.
32. That's all we're doing when we're evaluating these functions, right? Just like we did before. We did it last unit even. Does that make sense? Do you have any questions on that? All right, I'm going to keep going then. So that's already one thing checked off. 3 to go. Yes, AJ?
Did you get a homework?
Yes. Did I bring one? I got my back. So, the next thing we're talking about, whenever it says finding solutions, that's the same thing as zeros, roots, right? X-intercepts. We just talked about on a graph, the solution is always at the x-intercept. Nice, man.
I did already.
Try to hide it.
Hide what?
What?
I'm not trying to hide it.
Yeah. I'm taking notes today. Thought you were making
I left
coffee.
all my stuff at home yesterday. I told you that, so I took them with me.
Unbelievable. I just got all the excuses.
I really do.
Alright, so all of these mean to find the value of x when the function equals 0. Or find the x-intercepts, right? So if I look at a graph, I look at this graph here, my solutions are where I hit the x-axis. Right here, I'll extend it so you guys can actually see. See AJ, have a good weekend. Thanks. So my solutions would be at -1 and -3, right? Where it hits the x-axis, right? Right? So I have 2 solutions. Well, let's think about it then. What does it mean to have 2 real solutions? 2 real solutions means it's going to cross the x-axis twice. Right? We see that. Every time it crosses, I have 2 solutions. Well, if we're going to have 1 real solution, what do you think would happen?
No, one real solution.
how many times would it cross the x-axis? 1. But we're dealing with parabola, so can a parabola cross the x-axis and then never come back? No. So what's going to happen is if I have 2 real solutions, right? 2 real means it hits it twice. Oh, I'm going to skip that. I'll come back to that one. 1 real means it touches the x-axis at the vertex. Right? So every time it hits the x-axis, I have a real solution. So 2 reals means it crosses it. 1 real means it's just going to touch it and then start going back up. All right, now there's one other type of solutions we can get. That's too complex, right? When do you think that's going to happen? And? When it doesn't touch the x-axis at all. So we might give you problems on a test or on a homework and say, how many solutions do these actually have? And what you're going to be expected to do is you're going to be expected to put them in your graphing calculator, right? Y equals, let's say, x squared plus 8x plus 25. And you have to look and see, well, does this actually touch the x-axis? If it hits it twice, you know there's 2 real solutions. If it just touches it once at the vertex, you know there's 1 real solution. And if it never touches the x-axis at all, you're going to have 2 complex solutions. Alright, so let's practice that. So take your graphing calculators out, please. And the first one I want you to put in is y equals 2 times x minus 3 squared minus 5. And I'll do it as well. Y equals, I hit the wrong thing because I can't type. Y equals, we might want to turn, guys, remember we had our plots on last unit? We might want to go and unhighlight that. So turn your plots off. Y equals 2, parenthesis, x minus 3 squared, minus 5. Now I'm going to see, does zoom 9 work for this as well? Let's find out. Zoom 9. It does. Okay, so let me go through that again. You go to y equals.
Did you turn your plot off?
Make sure your plot is turned off. We had plot 1 highlighted from last unit. Highlight it again, hit enter and go back down. It should be unhighlighted then. Because otherwise that's going to plot anything you have left in your stat edit. We don't want that. Then you go to y equals, go to the first one, put in 2 times x minus 3 squared minus 5. If you don't know where the x button is, it's the one right next to alpha. Okay? Are we all to this point where we have it put into y equals? We all know how to put it into y equals. Okay, to graph it, there's 2 ways you can do it. You can do the zoom 9 method, like we did last unit, and that'll fix your window right away for you. Or you can hit graph, and you might have to mess with your window, because your window might not be normalized. What happens when you do zoom 9, oh, I don't want that. You do zoom 9, it automatically changes your window so you can see it. Right? Now, look at your graph. Does it cross the x-axis? Does it touch the x-axis? Or does it not touch it at all? It touches and it crosses it, right? It goes down and it comes back up. So it hits it how many times?
Oh.
Twice. Look, it hits it here and there.
It's a double whammy.
So what type of solutions would I get from this? I would get 2 real solutions. Alright? Did we all get that? No? Okay, let me come check. Does yours say it too?
No, mine says no. But like,
Yours says nothing.
dot says the X and Y. Is X 61 or Y 6723? Because I got X.
I like and then hit true.
If your zoom 9 doesn't work, what I would suggest you doing is I would just go to your window. Not your zoom. Go to your window. Set your x minimum, let's say at, let's start with negative 10. X maximum 10. X scale 1. Y minimum negative 10. y maximum 10, y scale 1. See if that works. That's the one you should always start at. Hit graph.
Oh, I got it.
Wow, it looks so much better.
Okay, it's a little more zoomed in than the Zoom 9 does, right? If that doesn't work, if negative 10 to 10 and negative 10 doesn't work, make it bigger. Go negative 50 to 50. Negative 50 to 50. Right? Keep expanding your window until you actually see your graph. I'm assuming most will work with negative 10, 10, but if you have to keep expanding it, keep expanding it. Okay? Did everyone have a problem before and get it to work now?
Yes.
Did you get it to work? Okay.
I finally got it to work.
Alright, try the second and the third one, please.
I'm just literally shaking.
Use anything saved on here that they can't be erased. You haven't changed anything and said anything.
That's just how the tool is.
Yeah, it's up to you. The minimum's that be negative 10, the maximum.
Oh, it was supposed to be now? Yes. Oh, what are you doing? Oh my god, that's scary. 'Cause it's like,
Okay. Did everyone get the other ones? So let me put the other ones up here quick. Y equals x squared plus 8x plus. Oh, I'm doing the wrong one. Plus 20. And the other one was negative 3. Minus 4. Okay, so the blue one's the second graph. And the red one's not coming up. Oh, there it is. Okay. So the blue one's the second graph, the red one's the third graph. So the blue one, I'll get your question in a second. I'm not ignoring you, I promise. Okay? The blue one, what type of solution should I have? Too complex. It never touches. The red one, I should have one real, because only the vertice is touching it. Alright? Does everyone get the sense of how to do that? How to put that in your calculator and check it?
Yeah.
Okay.
Yeah, so I put the second one in my calculator and I did the Zoom 9.
Okay, so what is going to happen is you can see it touches and then it doesn't go back. So what I would do, honestly, Sarah, I maybe just do the negative 10 to 10.
How did I make that?
The Zoom 9 is a little bit farther zoom out. You see more of the actual curve compared to just seeing what it touches. You graph
I'll see
that.
if my car starts and then.
Okay. So guys, I would maybe stay away from Zoom 9. I got you stumped, Sarah. Shh, listen, Zoom 9 is going to get you to see more of the curve. But like her second one, it looked like it was touching the x-axis. So I would maybe stay away from that. Maybe stay negative 10 to 10, negative 10 to 10 when you're doing these. And then if you need to expand it from there. I don't think many of them will be outside that. Okay? Zoom 9 gets to see a lot more of the actual curve. Okay? Any questions on that? Yes? No? Okay, can I keep going? Alright. So, back to kind of the stuff we were doing yesterday then.
It doesn't have.
Converting forms, except we're going to have a number that's bigger than 1 for a, right? Yesterday, every a value was only 1. Changing forms would be a lot similar, even if that a value is greater than 1. So for this one, y equals 4 times x plus 2 squared minus 1. Yesterday, we just FOILed and combined like terms and we were done, right? We're going to start in the same direction. We're going to start by FOILing. So I'm going to rewrite it. Y equals 4 times x plus 2 times x plus 2 minus 1. So the first step I'm going to do is I'm going to FOIL. First, outside, inside, last. Y equals 4 times x squared plus 2x plus 2x plus 4 and then minus 1. The second step, we're still combining like terms, but we're only combining what's in the parentheses. So y equals 4 times x squared plus 4x plus 4 minus 1. Okay, what do you think should be different now? What do you think we're going to do now? Distribute. You got to distribute that a value. It's no longer 1. So I have to distribute it into those parentheses. So y equals 4x squared plus 16x plus 16 minus 1. And I have one last step where I need to combine that like term at the end. 16 minus 1 will give me 15. So y equals 4x squared plus 16x plus 15. So not much is changing here. We're not changing a whole lot of our process going from vertex to standard. We're still foiling, we're still combining like terms. Now we have to distribute that number in. Does that make sense? So just a little more solving before we get to our final answer. So let's try it again for the second one. Y equals 2 times x minus 3 squared plus 7. So x minus 3 times x minus 3. Remember, you cannot just distribute that squared piece. It will not work out. Y equals 2 times x squared minus 3x plus 9 plus 7. Okay, so we FOILed. We're going to combine like terms inside the parentheses. We get x squared minus 6x plus 9 inside. Don't forget we have that 2 in front. We have the 7 behind. Well, once we've FOILed that, once we've combined like terms inside, then we can distribute. Y equals 2x squared minus 12x plus 18 plus 7. And then your last step, add 18 and 7. Alright? I know I went really quickly on those, but I feel like those are pretty easy. Right? Are there any questions on that? Yes, no? Okay. Can we keep going?
Yeah.
Okay. So that's vertex to standard when a is greater than 1. Standard to vertex form. When a is greater than 1, it's going to be a little bit of a different process. It's going to be a lot the same, but the way we start it's going to be a little different. So we're still going to take our x squared term and our x, and we're going to set them apart. What's going to happen here, so I'm going to take them, I'm going to set them apart. Y equals 4x squared plus 16x plus 7. But what I'm going to do once I set them apart, once I put them in those parentheses, is I'm going to factor out a GCF. Because what's hopefully going to happen is I'm going to get this x squared term to be just 1x squared. So you'll notice I take a 4 out of both 4 and 16, and I get 4 times x squared plus 4x, left a space, and plus 7 still on the end. So it's a little different. We still set it up the same, but now we have to factor GCF out first. Then we can get back to doing what we did before. We can take our b term, which our b term is what here? 4. We are going to divide it by 2, just like we did yesterday. 4 divided by 2, which equals 2, and then square it. Okay? I'm still adding 4 on the inside then. That's what I did here. However, when I add 4 on the inside there, I can't just subtract 4. Why not? And?
Because you took away the exponent, or the...
What? I think you're right. I think you're on the right path. What happened? What did I do up here?
You divided by 4.
I divided by 4. Right? I took a 4 out. So what's going to happen is if I add 4 in here, I'm going to subtract by 4 times 4.
What?
Because if I had redistributed this, it'd be like I added 16. Right? Does that make sense? So what's happening here, I don't like how this is set up one bit. I apologize for that. But because I add 4 on the inside, if I were to redistribute this 4 that I left out front, it was like I added 16, because 4 times 4 is 16. So instead of subtracting 4, I'm subtracting 16. So remember, I want to balance it. I want to add 0. I don't want to add more than I subtract or subtract more than I add. I don't want to change it at all. So because I added 4 in here, and I took a 4 out already, I got to do 4 times 4, and that's the amount I subtract. So that's the really big difference today, and a lot of people forget to do that. They're going to add 4 on the inside, they're going to subtract 4 on the outside. Don't be that person. Right? That person gets it wrong on the test, and that really sucks. Okay? Alright, can we try one together? I hated how that was set up. Can we try one together where I can write and everything too? Okay, let's do that. So, the first one, y equals 3x squared minus 6x plus 6. I'm setting it up just like we did yesterday. Y equals, parenthesis, 3x squared minus 6x, leaving a space, plus 6. Okay? Now, in order to complete the square, I want my x squared term to have a 1 in front of it. To do that, I have to take a GCF out. Well, I'm going to take a 3 out of both 3 and 6. Okay? So it becomes y equals 3 times x squared minus 2x, leave a space, plus 6. Do we all follow that part? Because if I'm going to want to factor it into x plus something and x plus something, or x minus something and x minus something, I'm going to need that x squared to be a 1 coefficient. So, then it's just what we did yesterday. Take your b term, take negative 2, and divide by 2. What do you get? Negative 1. And I square it, I get positive 1. So I add 1 on the inside. But I can't just subtract 1. Right, you're right. Because if I redistribute this 3, it's like I added 3 on the inside. Which means I have to subtract 3 on the outside. So what you need to do is take whatever you add, multiply it by the number you took out, and that's what you're going to subtract. Does that make sense? Does that make sense why we do it? Okay. And then, it's just like yesterday, y equals 3 times x minus 1, x minus 1. Remember, it should factor to the same thing. Plus 3. So it becomes y equals 3 times x minus 1 squared plus 3. And that's in vertex form then. Okay, does that make sense? Alright, we have a couple more to do, I think. We're going to do the next one together. Yes, Ange?
Where did you get the 1 again from up there?
Remember, I negative 2 divided by 2. Take your b term, divide by 2, and then square it.
Oh, okay.
Okay.
Wait, why is it negative?
Well, it's negative 2
okay.
divided. Okay. Hey, we're going to change this problem because I don't like how it's set up. Change this to 8x, please. Otherwise, it gives you a nasty decimal. We don't want to deal with that right now. We're practicing. I don't want to deal with that. If you come across decimals, they are okay to use. Fractions are okay. But I want a nice number for while we're practicing. Okay? So I'm going to do the same thing. Y equals 2x squared plus 8x, leave a space, plus 11. Well, I'm going to take a 2 out, so I want that x squared to have a 1 in front of it, right? So y equals 2 times x squared plus 4x plus 11. Okay. We good with where we're at?
Yeah.
What is my next step from here? Divide your b term. Good. So our b term is 4. 4 divided by 2 is 2. I square that, I get 4. So I'm adding 4 on the inside, but I'm doing 4 times 2, which is 8, and that's what I'm subtracting on the outside. Okay? Do we have any questions on that step? Okay, then we're going to factor. Y equals 2 times x plus 2 times x plus 2 plus 3. 11 minus 8 is 3. Last step, change x plus 2 times x plus 2 to x plus 2 squared. So y equals 2 times x plus 2 squared plus 3. That's my final answer.
Mr. E, what if 3 of these problems all had the exact same, like, factoring thing, like the x squared plus 4x plus 4? Because the example one had it, the one we just did had it, and the one next had it.
I don't know. I honestly, I just changed it off the top of my head because I know it's going to be an ugly decimal.
Okay.
Hey.
It's for Kenzie.
Okay. It's not on purpose. I mean, there's only a certain amount of ones we can use, but It happens. Okay? Alright, here's what I want. I want you to try convert it to vertex form. I know you can all convert to standard. I know you can FOIL. See ya. Got that on camera.
Really?
Go. Get out. Okay. Do the first you try. Convert to vertex form. Once we've finished that, I'll hand the homework out. Can I check it?
Yeah, I did.
Sure. Let me double check my answer before I can call you. No. Once you show me you have it done, maybe you could. On what? Putting scratch paper in the back.
Mr. Reed, you edit your videos?
I did not edit the videos at all.
You don't cut anything out?
Nope. What?
So this is all on video.
Everything's on video. I don't hide a thing.
Uh-oh.
How'd you do that?
We have to do both.
Nope, just do one of them. You can do both for practice, but I'm just asking you to do one of them.
All of it.
Because the standard form, that's the easy one. I want you to try converting to vertex form. That's a hard one. Swipe up, subscribe.
Russia.
You got it?